Good afternoon, everyone. My name is Maxime Kouassi. Currently, I'm a master student in Information and Communication Engineering at Kitami Institute of Technology, a graduate school of engineering located in Japan, precisely in the north in Hokkaido Prefecture. So, first of all, I would like to thank the organizers for the given opportunity to present our work at this prestigious conference. So today I will be presenting the research that I am working on at the university as part of my program. So this research is based on espresso extraction. So in this research, we are aiming to use data science and AI techniques methods in the optimization of in the extraction process of espresso coffee. So today I will be presenting the current state of this research. So as we can see on the screen, the topic of today's presentation is towards optimizing espresso extraction, which besides espresso features correlate with overall subjective satisfaction. So here is the table of content of my presentation, the flow of my presentation. Obviously, I will be starting the presentation from the introduction. After the introduction, we'll dive into the overview of this research. What's the motivation of this research? What's the main goal, the main purpose of this research? And after that, I will be presenting the workflow. What's the map of our research? What's the different step of the research? And after the workflow, I will be presenting the first results that we already got in this research, and I will conclude my presentation with the future work. So, coffee is today playing a crucial role in our daily life. So, um, it's one of the most consumed beverage in the world, and it's also enjoyed for its quality, its flavor, and also its benefit in our daily life. Coffee can have several positive impact in our nervous system, can have a positive impact in our production, um in our work flow and our performance and so on.
Now let's talk about the overview of our research. First, what is the motivation of this research? What motivated us to start this research? First, it's for quality concern. So, when it came to make espresso, there are several parameters that came into play. So, the way we use these parameters can have a significant impact on the final quality of the coffee. For example, today baristas, for example, can rely on the expertise on making espresso or rely on the experiences on making espresso coffee. But sometimes we don't make espresso based on any scientific base. So in this research, we are going to find a scientific base to make espresso coffee better and good. And also, we are aiming to improve to promote the sustainability of the environment. For example, if instead of using 92 degrees Celsius to brew espresso, if we can reduce the temperature to maybe 80, or I don't know, maybe 79, 78, you see we can save some energy. Or additionally, if we optimize the flow and pressure that we use for espresso, this can help us to have to use the necessary amount for water of water for each shot. So this can also help us to minimize the waste of water. So by improving the efficiency of the espresso process, we can deliver high quality coffee while we reduce the overall consumption of resources, making the process more environmental friendly. What's the problem that we are going to solve through this research? The problem is simple here. How we can use, how we can optimize these extraction parameters in order to improve the taste of coffee, in order to improve the final outcome of coffee, and reduce any negative impact on the environment. So the main of this the goal, the objective of this research is to leverage data science techniques and causal inference for this optimization of those parameters. So with these techniques, we'll be able to find a scientific base to make espresso better, to improve the quality, the taste, the final outcome of the coffee. The main purpose of this research, the final goal of this research, will be to build an AI model that can fit coffee customers' preferences while having a sustainable impact on the environment. So, in this research, we are using this machine. This machine is a decent espresso machine. It is an intelligent machine that is able to record all the information about the shot we make. When we make coffee, this machine can record the temperature of the coffee, the flow, the pressure, water pressure, the and say other several parameters about the shot we make. So when we make the coffee, as I said, all the information of this shot about the shot are recorded in the cloud of the machine. So we have this batch of information on the cloud of the machine. And we give the coffee to the customer. After the customers enjoyed his coffee, after they enjoyed the coffee, we ask them, please, we have a survey for you. Please, could you give us your feedback about the coffee you just drank? What do you think about the aroma of the coffee? What do you think, for example, about the richness of the coffee? So this kind of question we are asking them to our customers. So we have one source of data from the matching, that is the objective data, and also we have the subjective data from the customers about the preferences or about the taste. And the next step is will be to analyze this subjective data from customers. So, and after analyzing the subjective data from customers, we'll also be analyzing the subject the sorry, after analyzing the subjective data from the customers, we also be analyzing the objective data from the matching. So we here in this part, we'll be try to understand what's going on the data, what's the behaviors of each extraction parameters. And after this separate analysis, we are going to do a combined analysis. So we'll combine both information, subjective from customers and also objective from the matching, and analyze. So in this part, we'll use, as I said, we use this part we are going to use causal inference techniques. So causal inference is a statistic techniques that can help us to understand what's the impact of, or what is the influence of each single parameters on the final satisfaction, or on each single features of the coffee beverage. So after doing this, all of this analysis, and find the insights from the data, we'll be able to build our model, as I said, that can fit coffee customers' preferences.
So in this research, please note that we are not using any existing datasets. We are creating our own datasets. As I said, we have this coffee matching that can record the information about the shot. We have some, for example, the actual temperatures and go temperature, actual water flow and go and so on. So, for example, what is actual temperature and what is go? The actual temperature is the temperature that has been used for the coffee for the shots, and the go is the temperature that we set manually, because before we use the machine we have to set the parameters. Okay, for my coffee I want this temperature, I want this flow, I want this pressure and so on. But when the machine is making the coffee itself, it has the actual temperature of the shot. So this is the difference between actual temperature and cold temperature. So the machine has can record all of this information. And after that, we also have a second source of data sets, as I said, a survey from coffee customers. So this is the QR code of the survey. So in this survey, we are asking them to rate some features of the coffee. For example, we give you the coffee we drink, and we ask you, what do you think about the aroma of the coffee? What do you think about the bitterness? What do you think about the richness of the coffee? And so on. And after that, we are asking them the overall taste, the overall satisfaction from the about the coffee. So this all of these scores are rated in the range from 1 to 5.
So, here is the table summarizing the data we already collected. When we take, for example, the sample size column, we can see that we already collected 830 shots and 151 responses from consumers. This gap between both sides is because we bought the machine sometimes before we started the research. So, as soon as we bought the machine, we started using the machine, and all the shots that were made has been recorded on the machine. So, after we start this research, we still have collect the information about the shots recording in the machine. So when we extracted this information from the machine and also our responses, we try to find out which shots correspond to which response. And we found that 164 shots correspond to 134 responses. This is because some responses have two or two plus shots. And we did a second matching to see which single shots correspond to which single responses. And we got 109 shots and 109 responses matching 1 to 1. For the first analysis, we started with the subjective data from the customers. So as we can see here, here's some insights on the of our data. We collected 81 responses from male and 28 responses from female. And 67 responses are from age range of 40, sorry, and 27 from 20 years old, 39 responses from 30 years old, and 4 for 50 and 2 for years over 60 years old. And also we ask them the to our customers their preferences about the type of coffee, and 60 responses from espresso, uh, 36 from coffee latte, and 9 from americano, and 4 from lungo. And also we ask them what is the amount of consumption um, about coffee. And 63 responses consume a few cup of coffee per week. 28 consume a few cup per day. 14 a cup per day. 2 a cup per day. And 2 rarely drink espresso or rarely drink coffee.
That we did some correlation analysis. So as we can see here, aroma, concentration, and richness positively correlate with the overall satisfaction, with a high correlation of aroma and richness. So we can say that these features are increasing and decreasing together with the overall evaluation. Regarding the bitterness, it's negatively correlated with the overall satisfaction. So that's when the bitterness increase, the overall score is decreasing. So this convey the fact that, of course, when the coffee is bitter, more the coffee is bitter, less people like the coffee, and this vice versa. And when we take a look at the p-values, we can see that aroma, bitterness, and richness are statistically significant while correlation is not. And also, aroma, bitterness, and richness have a meaningful relation with the overall evaluation of coffee consumers. So, as a future work in the near future, we already did the analysis of the responses we got. So, in the near future, we plan to do the analysis, we plan to analyze the extraction parameters, the information that we got from the matching. We'll analyze how what's the behavior of the every parameters, what the behavior of the water flow, the water temperature, and so on. And after this separate analysis, we are going to combine both data sets from consumers and also from the machine, and analyze them. Analyze, create one data set and analyze, do analysis. So here we are going to use causal inference techniques to understand what is the effect of each parameters on the features of the coffee. So causal inference is a technique that can help us to understand deeply what is the inference, what's the effect of those parameters on the coffee features, and finally on the overall satisfaction of the customers. And of course, after all of this analysis, we plan to extend the size of our data set, because to have, in order to do a very deep or robust analysis and build a robust model, we need to have a lot of data to train our model, a lot of data to understand and then train our model for a very accurate model as much as possible. So in the new future, we also plan to extend to get as much as possible data from both sides, from consumers as well as from the coffee machine. And finally, we'll be able to build our model in order to fit coffee customers' preferences, as I said so far. So that's all for my today's presentation. Thank you very much for your attention. And please, if you have any question or any comments, please let us know. Thank you again.